Good morning. Howdy, howdy. We're here, back again after a long weekend. Well, not long. Just stubbed my toe pretty hard, so I was a little bit hanging out and not doing much, but that's how it goes sometimes, right? So we got all the pieces printed, um, all of them. So this is what the main-ish handle blaster trigger looks like, and it didn't turn out too bad. I think the trigger could set a little farther forward, but for now, I mean, yeah, the trigger definitely needs to sit farther forward. It needs to be way farther forward, but that's okay. For right now, the test piece, this is gonna be cool. I started to nut and bolt it together. Nothing too fancy. I gotta take it all back apart because I gotta install all the internal pieces. So I was kind of thinking I wanted to play around with it a little bit. Ooh, that's tight. That's tight. Need some better snippers, but that's okay. That could just be the wrong end. No, that's the right end. There. That's loose. I don't know why is that tight? That doesn't make sense. Oh. I don't know. I think I've still got some dialing into my printer to do because I'm seeing little gaps in the print walls. It doesn't really matter too much. Not for this print anyway. Yeah, so we're just gonna hang out. I'm gonna do some design changes. There's a few things I gotta change. Just because. Specifically in the, yeah, we're actually going to change it that way because why not? Okay, so we're going to roll this back. And we're going to change this stuff. There, that's what I want to change. Okay. No, where's the split? That one. Yeah, and then, oh, that's where I put that. That can disappear. That come back to there. Oh, that was another thing I needed to change. The pivot where this, right in that area, is not right. I didn't constrain that right. Let's see. Yeah, so technically there and there, that's not right. What needs to happen is, and then we're going to go tangent x. We're going to get rid of that, and we're going to get rid of this. And can we? Oh, we can. Look at that. Sweet. Okay. Now, That technically should be a little bit bigger. .265. That's better. Okay, cool. That changes that. That's what I needed. That way when it actually pivots, it's not, because it runs into itself right now, and I don't want that to happen. Okay, that's changed. That design, what is that? Handle split, okay. Because I technically want to, yeah, okay. Because I printed the middle pieces, these first, just to get the handle done. It wasn't a mistake. It just was I rushing things, maybe. What I needed to do is I needed to add a little bit of a gap because these overhangs are not fun. Yeah. And I'm trying to think, can I? Yeah, okay, these can be. Okay. That's not okay. Ooh. Okay. Well, we got to come back. Let's see, handle split. And we're going to edit this. Because technically it's not going to enjoy that much at all. So then we can sketch, we can, no, we just need this. Was there something else? Yeah, that, but we can do that later, I think. Anyway, I think we can. Because we're not reprinting the whole thing. We're not going to do that. We're not going to change that, but we are going to change this. This is going to make things easier to assemble and less cleanup, because you want as little cleanup as you have to do when you 3D print. I mean, there's always going to be cleanup that you're going to have to do, but I always try to make it where there's not a ton of cleanup afterwards. Just the way things are. Alright, so we split all that up. That doesn't need to be like that, but it is what it is. How did I extrude? When did? Oh, okay. Yeah, that could be the way it is. That's okay. It's not going to change anything. That's a good question. I don't have my notebook up here. I should, sort of writing stuff down, but sometimes you still wanna. You just wanna do what you do. And this is very much just an ad lib kind of day. Got a light coming from over there because I got my window open. The one behind me, I had to put a sheet up so that I could actually, you wouldn't just see like a halo. Come on. There we go. That's what I'm after. And you. I want you too. These are 1024s. The 1032s, the threads are a little thinner, and I just wanted a coarse thread for the front end for the hot glue. Not that it matters much, but it matters to me. Come on, all the way out, please. Almost there. There we go. Okay. How close are these to being same height? Oh, oh, whoa. That's a lot different. That's not great. Can I even measure that? Ooh. No, I cannot. Six is the maximum, and these are just a little over 6. Well, that stinks. So which one's wrong? I don't have calipers that are big enough. So these two pieces are not the same distance, and that's not great. That means one of my, because one of them was printed in one orientation, another one's printed in a different orientation. So one of my distances is off on my 3D printer, and that stinks. I don't know which one to trust more, my Z or my XY. And honest to goodness, I trust my Z a lot more than I trust my XY. So I have calibrated and calibrated and calibrated that printer, and it still always decides to go, yeah, I think we're going to change. We're going to be different. Maybe. I can get a distance. It's not going to be a great distance, but I can get a distance. 5612. (561). Now, did I just change something? I don't think I did. I think that's actually going to stay the same. (5625). Okay. I mean, that's That's actually not bad. That would mean that the Z is off by a smidge, which well, there's 2 3. Okay, I trust my XY. I don't trust my Z anymore, which is unfortunate. Because I wish I could, but I think that's actually... Five, 3, 3, 6. What? That one might not. Because I'm... Five, 5, 6, 4, 7. Whew, that's a funny number. And if that's off by what? 5, 6? What? 5, 5, 5.5, 6. Oh, that's way off. No. My calipers are reading funny. Okay, that's a little more better. Come on. 5, 5, 4. Yeah, that's a little... 6, 4, 5, 5, 4, 5. Yeah, that's... My Z's off by 10 thousandths, which isn't a lot, but it's a lot. So I guess what I could do, if I wanted to, just to even things up a little bit, put a piece of tape on the back of the front of... I think I want my backs to stay the same. I think the front can change a little bit. So if I can find like tape that's about 10 thousandths or 5 or 2 and just layer it up real quick, I'd be a little bit more comfortable with that. Whoa. That's not great. Oh, that's super tight. What? That's super tight. What's up with that? Oh. Nuts. Yeah, that stinks. I'm just getting dimensions and measurements of all my pieces, and that's not going to work. 8, 7. Ouch. Ouch. 196 into 187. Well, that's minus the 180. Oh, yeah, that stinks. 82, 81. Well, that whole piece might need to be reprinted. Nuts. Oh shoot, in that case I might have to recalibrate the whole printer. Now I've got a different way of thinking about calibrating that printer. There's other things that need to work on that printer too. My corners are always bulgy. I like to take care of that. I mean, they're never going to be pointed, but they're, you know, they've got this weird sort of thing going on. And I know there's some settings you can work on in order to fix that. It's just a little bit more complicated than I'd like to get into. This piece is fine, I think. Yeah, that's fine. I mean, mostly a little tight right in there, but again, I could change that, the settings, especially after. So there's a few pieces I'm gonna have to reprint. That's just where it's at currently, unfortunately. I mean, I could sand and shave this, but that's tight. That is really, really, really tight, and that just stinks. That piece is tight too. All right, well, I'm going to do a little research into how to get the printer to print better. There's a video that I watched a while back that kind of explains settings I need to change in order to get it to print better. I could just spend the day doing that, which is kind of fine. Just not what I wanted to work on today. But maybe it's needed. Changes my test block a little bit, but that's okay. I think that's what I'm going to do today is work on and then from there we'll work on other things. So I think that's probably what I'll start doing is just, and I'll stay on the stream. I'll just kind of I'll just kind of be here, and if anybody has questions or whatever, you know, I'll just be here. What I'm gonna do. What am I gonna do? I don't know what I'm gonna do. I could just keep it like this and then pop her over, and we'll just swoop, and that'll all be funky. But hey, you know what? Yeah, I'll check in periodically and make sure that you guys are all doing good. This is the page I'm kind of working off of, and I can't remember who it was. If it was Joel 3D Printing Nerd, or I probably just mixed two of them together. One of the guys said that he used this and really tuned in his 3D printer using this framework. Yeah, this guy.
Have you just got your first 3D printer?
Who was this guy? Teaching Tech. Is that actually the guy?
So you might be
Yeah, this guy. I was watching this guy, and he has this. I don't know if this is his, but it could be. This could be the guy. Okay, this is. Okay, that's that. First layer, baseline print. Yeah. Okay, so this is initial print after you've made sure your printer's all tight. Oh, okay, this is. This is flow rate. Okay, and this is kind of what I've been struggling with a little bit. I think I need to flow a little bit more because, well, in some pieces, the walls aren't quite sticking together as much as I wish they would. Under extrusion, yeah. That's wall thickness, and so that's like There might be a setting in Kira for that where it talks about that could be close to what I'm thinking about. Yes, that might be okay. Not that, but these two are the ones that I need to play with in order to get it to work right. Compensate wall overlaps. What does that mean? Okay, that's not quite the setting I thought it was going to be, but that's inner wall overlap. Okay, yeah, that makes sense. Multi extrusion. Okay, that, yeah. Outer wall wipe distance, yeah, outer wall inset. Mm-mm. Okay, that it probably will come down to, and once I find that the one I'm after, the setting I'm actually looking for, because it's pretty cool. Not that. Although I would like to upgrade that. That's temperature and stringing. I had that problem. Fixed it using this. Don't need that. That's not what I want either, I don't think. Surface artifact. Yeah, I don't care about artifacts. Ghosting. Not quite what I'm after. Still not what I'm after. There was something in here that I got all figured. That helped. This not quite what I'm after. No. Baseline print. No, I'm trying to remember. Not. Temperature tuning. I don't think that's. No. Mm-mm. Man, there was a setting in here somewhere. Oh, this is it. This is the one. Okay, it is this. This picture right here. This. Because you can kind of see decent bulge, decent nothing, and then decent. And this helps with your corners. I think this is the one. Yeah, the timing of the extrusion with the aim of reducing swollen corners. There it is. And I deal with this so badly. I really this is what I was looking for. This is what I wanted. I'm just reading what kind of and
Want to improve your print quality for free? With Marlin's Linear Advanced, you can do it quickly and easily. The deeper explanation and then jump right into a forward test print. Linear Advance aims to decouple the movements of the extruder stepper motor, shifting them slightly to control the nozzle pressure and alleviate this problem.
Mm-hmm.
If it's tuned correctly, we should see these bulbous edges almost disappear. Linear Advance looks ahead and precisely controls the pressure inside the nozzle by timing the stepper motor more appropriately. For this video, we're going to be following the main Linear Advance documentation on the Marlin website. It's a thorough page with everything explained well. I'll link it in the description so you can read further if you like, but we're going to skim through pretty quick now apart from a couple of main points. Got it dialed in. We'll save the K value before touching the firmware, embed moving back and forth and works. It's still really easy to interpret and to set the correct value. It's going to print a series of lines and the K value is going to be different for each one so we can make comparisons next to each other. So here is the calibration pattern generator. There's a lot of settings on the screen, but there's not actually that many that we need to use. Our main priority is making sure we get these base settings.
Linear Advance. I wonder if that's in Kira. Okay. Maybe not.
Correct. And if you're unsure on any of these specs, you can switch to your slicing pro, click generate, copy in any chances of collisions. Now generally all the speeds we can leave. So here is the calibration, making sure we get these base settings correct. And if
We're gonna pop over to YouTube, just cause.
settings correct. And if you're unsure on any of these to your slicing program and copy them from there. For instance, something really simple, I'm using a 0.4mm nozzle, and I can also get my temperatures from here as well. Also important to get right, because we want anything with a terminal and then send an M503. We can see here our maximum acceleration is there, and we can copy in the value. For me, mine is default, so everything matches. Now for the first run, we're going to leave everything standard for the pattern, but we will come back and tweak this if we need to for fine tuning later on. This bottom, preview it, you can put it on your SD card and run it from there. I'm going to run mine connected directly to the printer just to speed things up. Here we can see the calibration printing, and it works as follows. It starts on the left hand side with a slow move, then has a fast acceleration through the middle, followed by a slow move on the end. When this main pattern is finished, it comes across the top, draws two vertical markers, and then fills in the K values on the right. When we're interpreting the test grid pattern, we're looking for the most consistent line without these artifacts. With that in mind, we can interpret the standard pattern that goes from 0 to a K value of 2. My most continuous lines are right down the bottom, so what I want to do is run a second test where I retest in more detail around these areas and I discard everything up here. So back on our pattern generator, we're going to come down to pattern, and instead of having an ending value of 2, we're going to set that to 0.4, and then we want our stepping to be a lot finer since I've got a much smaller range, so we're going to put that down to 0.05. Now we scroll down to the bottom, we go generate G-code to update what we have here, and then we download the file and run the test again. Here's the new G-code. Apart from the 0, we can see we have 8 new variations to try, and this will help me further narrow down the exact value that I want. We need to remove the old pattern, and I recommend a credit card to clear the bed quickly, ready for the new one. The best thing about this test is it's over in about a minute and uses very little filament. Here's my second test, and once again we're looking for the most continuous, consistent line, and we can see that the upper half is still not the best, and our best values are probably somewhere around the middle here. So what I'm going to do is one final test, honing down on these values here. So hopefully this will be my final one. I've run it from 0.1 to 0.2, and that should give me the required detail to choose my final K value for calibration. So on this final one, they look almost identical. We can see some subtle bulging up here and a little bit skinny there, but down the bottom I think is still the strongest values. If you're struggling to tell the difference, then probably any of those K values would be correct. I'm going to settle on this one here. I think that's the most consistent, and that would be 0.11. So I have my chosen K value of 0.11, so I'm going to enter an M900, and that will tell me that it's currently set to 0, and then I can do M900 K 0.11. Now I should be able to save that to EEPROM, and it should be stored for future prints. Now alternatively, you might want to test this for all of the different filaments that you have, because you'll find flexibles will be quite different with the
Okay, after I mute myself. Yeah, I gotta plug it into my printer. I've got a cable. Cool. Is it long enough? I don't know. Probably not. It'll get me close. Maybe we'll run an extension cord. Alright, I'll be right back. Alright, let's pretend like we know what we're doing. And we're going to plug into the printer. I think this first time I've done this. I don't know. Alright, we're going to go to Marlin. And we're going to pretend like we know what we're doing. And try to follow.
Value required.
I think he's got. Cool. Oh, does it? No, I don't have that. Home wall axis, yeah. Okay. Let me. K factor 2, okay.
Therefore, you could put the M900K line in your start G code depending on your specific filament, then it should be in place automatically for any of your prints. One more thing before we print the second test cube, there are some slicer changes that we need to make. You can see here it tells us to turn some things off. So for instance, pressure advance, coast at end, extra restart length after retract. It also says to turn off wipe while retract or combing. It might be called something different depending on the slicer that you use, but hopefully you can find the correct setting. We can see some of those settings in Simplify 3D. My extra restart is already set to 0, and I need to turn off wipe. Coast at end is already off, and in the advanced tab there's an option there for wipe as well. Here's my before and after test cube side by side, and hopefully you can see immediately that the bulges are vastly reduced. For the y-axis, the result is not as profound, and that's because we have a much heavier carriage moving back and forth with more inertia, and we can still see that little bit of ghosting. Overall, our extrusion is a lot more consistent. I recently ran the same procedure on the SK Go from Secit, and it's Core XY, which means it didn't suffer from any ghosting on the X or Y. Going through this process allowed me to print this absolutely beautiful benchy. It won't cost any money, so if you're willing to put in the time, this is a very worthwhile process. Once you get going, the whole process is actually quite fast to do, and I hope you agree that the results, while not game-changing, are definitely worthwhile. From the old to the new, you'll need a new cable.
Okay. that setting pretty high, actually. Let's see. Serial speed. Retract distance. Retract speed is 100. Acceleration, yeah. I guess I don't know what my jerk is. Oh, okay. 5, yeah. Sure. Ratio between the extrude. Oh, okay. That means it's going to print thicker. I guess that makes sense. Okay. Go to downloads. Oh, I guess I gotta hit print. Now we're printing. Cool. Well, we'll see how this goes. It's warming up now. A few people I gotta get a hold of. Where are we at? Okay, preheat, G-code, all that fun stuff. Okay. Anyway, getting close. I'm gonna hop down here to watch it. I guess I could set this up, but I'm just gonna hop down and watch it. Ugh. I'll be back. Ow. Alright, we should be getting pretty close. Yep, here we go. Should be anyway. Uh-oh. Oh, there it goes. Distance key. That was pretty close. Alright. Bill. I don't know which one looks better. I just don't know. Huh. I need a better light down here or something, I guess. I don't know what's going on. Being it's a Bowden extruder, I mean, it's kind of difficult to think. Well, in my opinion. They're all just about the same if you ask me. I don't know if it gets better or worse. that's not fun to watch. Like, it didn't change much. There's subtle changes, but nothing overly extreme. Like, I like 2. We're going to generate that code again and try again. Alright, we're going to generate that code and try again. This time using probably 2 to 4 and see if that changes anything. Because I like 2 the best for some reason. Alright. Well, let's try again, shall we? We're just going to keep pretending like we know what we're doing. Anyway, howdy to my 2 viewers. How are we doing today? Right now we're just seeing about this K value thing with 3D printing, and yeah, just kind of seeing if we can make it work for us or not. Well, we'll see. I don't know. Anyway, this is kind of what we got printing. And so far, I haven't really noticed too much of a difference yet. But anyway, maybe that's not the answer I was looking for. I don't know. Well, anyway, I don't know. I think I'm going to call it a day for now. Um, and then we'll see. Yeah, I'll keep playing with it, I guess. Oh,
Value for calibration. I'm showing that's linked in the description. Your test model should have sharp corners. K value is going to be different, 0.4, that many that we need to use, because we want this model in the center. This bottom section is called advanced, and it's, you can see here our maximum enter via Prontoface or Octoprint, anything with a terminal, and then send an M503.
well, maybe I want to. I don't know. Is there a spot where I can monitor? Hmm. Not well. the old one? Two point 7.0. Ah, that is the old one. Hmm. That's not what I wanted. That's what I wanted.
You can see here our maximum acceleration.
Okay. Well, anyway. Alright, well, I'm kind of done for today, I think. I got a few things I got to do. But, yeah, so I kind of started printing, or assembling certain pieces. And, yeah, I'm still not. The printer is still not calibrated the way I want it to be calibrated, but we'll get there. And I'll let you know what it looks like when I'm done. I guess either I'll work on it later today, or something. I don't know what, because I really don't want to print anything else until I get this figured out. Because it'd be nice to have a printer that actually prints nice. But anyway, so the K factor is something I don't guess I need, but I got to figure out something else. Alrighty.